Artificial intelligence and machine learning. Artificial intelligence, AI, and machine learning, ML, have rapidly evolved over the past several decades into transformative forces that are redefining entire industries, altering how we interact with technology, and reshaping the boundaries of human capability. AI refers to the broader concept of machines designed to perform tasks that typically require human intelligence, whereas machine learning is a subset of AI that focuses on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. The evolution of these fields has been driven by a confluence of increased computational power, vast amounts of available data, advanced algorithms, and innovative hardware, all of which have moved AI and ML from theoretical concepts to practical tools used in a broad range of applications. In the early stages of AI research, the primary focus was on creating rule-based systems that attempted to simulate human reasoning through a fixed set of instructions. Early AI systems were limited by their reliance on explicit programming and could not adapt or learn from new data. However, researchers soon recognized that the ability to learn from data was the key to unlocking more robust and flexible systems. This insight laid the foundation for machine learning, where algorithms could be designed to improve their performance iteratively as they processed larger datasets. As datasets grew in size and diversity, and as computational resources became more accessible, machine learning methods began to outperform traditional rule-based systems in tasks such as pattern recognition, language translation, and decision-making. One of the revolutionary developments in machine learning was the advent of neural networks, inspired by the structure of biological brains. Neural networks consist of layers of interconnected nodes, or neurons, that process input data, learn hierarchical patterns, and generate outputs. This concept has matured into what is now known as deep learning, which involves training multi-layered neural networks on vast amounts of data to perform increasingly complex tasks. Deep learning has been instrumental in achieving breakthroughs in areas such as computer vision, natural language processing, and speech recognition. Through the use of advanced architectures and algorithms, deep learning models can identify intricate patterns in images, understand the nuances of human language, and even generate creative content. The training process for machine learning models involves feeding them large datasets, which allows the models to adjust their internal parameters in order to minimize errors and improve accuracy. This process, often managed through techniques such as gradient descent, ensures that the models become adept at predicting outcomes based on input data. Supervised learning, where models learn from labeled datasets, has become the backbone of many practical applications, from classifying images and detecting fraudulent transactions to predicting consumer behavior. Unsupervised learning, on the other hand, allows models to identify hidden structures and patterns in data without explicit labels, playing a crucial role in clustering, anomaly detection, and recommendation systems. Reinforcement learning, another branch of machine learning, enables agents to learn through trial and error within dynamic environments, making it a popular approach for developing strategies in gaming, robotics, and autonomous navigation. The practical impact of AI and ML has been profound and far-reaching. In healthcare, these technologies are being used to analyze medical images, predict patient outcomes, and even assist in surgical procedures. Predictive models can sift through vast amounts of patient data to identify early signs of diseases such as cancer or cardiovascular conditions, enabling proactive interventions and personalized treatment plans. In the automotive industry, self-driving cars rely on machine learning algorithms to interpret sensor data, make split-second decisions, and navigate complex traffic environments with increasing precision. Financial institutions leverage AI for algorithmic trading, risk assessment, and fraud detection, while customer service operations use chatbots and virtual assistants powered by natural language processing to provide immediate support to users across different platforms. Moreover, AI and ML are integral in powering recommendation systems on streaming services, social media platforms, and e-commerce websites, where they sift through user data to offer personalized suggestions that enhance user engagement. Advancements in AI have also spurred innovations in robotics and automation. Intelligent robots, equipped with sensory input and machine learning algorithms, can perform tasks ranging from precision manufacturing to service-oriented roles in retail and hospitality. These robots are not only increasing productivity but are also assuming roles that involve repetitive or hazardous tasks, thereby improving workplace safety. Moreover, collaborative robots, commonly known as cobots, work in tandem with human operators, combining human creativity and decision-making with the precision and endurance of machines. This symbiotic relationship is redefining industrial processes and has the potential to significantly transform labor markets. The progress in AI and ML has been accompanied by significant research into ethical considerations and responsible deployment. As AI systems become increasingly autonomous, ensuring that these technologies are implemented in ways that are fair, transparent, and accountable has become a central concern for researchers, developers, and policymakers. Bias in machine learning models can arise from skewed training datasets or flawed algorithms, leading to unintended discrimination in critical areas like hiring, law enforcement, or lending. As a result, many initiatives now focus on developing fairer algorithms, rigorous testing protocols, and comprehensive regulatory frameworks that prioritize the ethical aspects of AI. Research into explainable AI aims to create models that not only perform well but also provide understandable and interpretable decisions, resulting in systems that are more trustworthy and easier to audit. Another critical aspect of the evolution of AI and ML is the concept of transfer learning, where models trained on one task are repurposed for another related task with minimal retraining. This approach reduces the resources needed to develop robust models and enables knowledge to be shared across different domains. By leveraging transfer learning and pre-trained models, practitioners can achieve state-of-the-art performance in tasks ranging from language translation to medical diagnosis without the need for enormous datasets or computational power for every new project. This efficiency in model development and deployment is crucial in an era where quick adaptation to new challenges is paramount. As AI and ML continue to mature, future trends point toward even more integrated systems that combine multiple modalities of data, such as visual, auditory, and textual inputs, into unified models capable of deeper contextual understanding. Multimodal learning is an emerging area that seeks to replicate the human ability to synthesize information from various sources, leading to applications such as advanced virtual assistants, holistic diagnostic tools, and improved human-computer interaction interfaces. The convergence of AI with other emerging technologies, such as edge computing and 5G connectivity, promises to decentralize computing and enable real-time processing of data. This integration will result in more agile and responsive applications, particularly in fields that require immediate decision-making, such as autonomous driving, industrial automation, and emergency response systems. The potential for AI and ML to reshape society is immense, and their impact extends to virtually every sector of the economy. In education, adaptive learning systems powered by AI can tailor educational content to individual student needs, tracking progress in real time and providing personalized feedback that enhances the learning experience. In entertainment, machine learning algorithms are transforming how content is created and consumed, enabling the generation of personalized media experiences and interactive narratives that engage audiences in new ways. Government and public sector applications are also on the rise, where AI-driven analysis of large datasets can lead to more efficient public services, smarter urban planning, and improved disaster response strategies. Furthermore, the accelerating pace of innovation in AI and ML is spurring significant investment in research and development from both public and private sectors. Governments across the world are recognizing the strategic importance of AI, leading to the development of national AI strategies and investment in research initiatives. Private companies are also dedicating vast resources to pushing the boundaries of what AI can achieve, resulting in a vibrant ecosystem of startups, academic research groups, and industry giants competing to develop the next breakthrough. This competitive landscape ensures that breakthroughs in AI and ML will continue to emerge, transforming the way we live and work in ways that are both exciting and complex. As we look ahead, the evolution of AI and ML is likely to be characterized by increased integration, higher levels of autonomy, and a continued focus on ethical deployment. These technologies will continue to drive efficiency, innovation, and transformation across myriad domains. The challenge for society, however, will be to ensure that these powerful tools are used responsibly and equitably, with a focus on creating benefits that are widely shared. Balancing technological advancement with safeguards for privacy, fairness, and accountability will be vital in maximizing the positive impact of AI and ML, while mitigating potential risks. In summary, the progression of artificial intelligence and machine learning from early rule-based systems to today's sophisticated, data-driven algorithms reflects a journey marked by relentless innovation and adaptation. The transformative potential of these technologies spans industries and applications, ushering in new levels of automation, personalization, and efficiency. As AI and ML continue to evolve, they will undoubtedly play a central role in shaping the future of society, driving decision-making in everything from healthcare to finance, from transportation to education. Embracing this evolution means not only capitalizing on the immense opportunities they present, but also managing the ethical, social, and technical challenges that accompany their widespread use. The future of AI and ML is one of uncharted potential, promising remarkable advances that will redefine what it means to interact with technology while forging a path toward a more intelligent, efficient, and interconnected world.